Okay, grade sevens. Again, I know a lot of these things you've already dealt with and you feel very comfortable with, but there are a few of you who are still having trouble with some of these ideas. So what we're working on is trying to get everyone on the same page when it comes to fractions. Now, I've tried to give you an idea of how to visualize fractions. That's what we use the strips for. Now I want you to get back to the idea that you're going to be doing it simply mentally. We're going to work on subtracting fractions from one another using common factors and common denominators. Now, I know you know how to do this. I know you feel comfortable with this, but I want you to practice just in case. So when we start looking at your power hour, you're able to pull this off without a problem. All right? Okay. So let's give a rundown of exactly what I want you to do so that you can do the associated work tonight. Here we go. Okay. By now, this should look really familiar to you. We're going to look at equivalent fractions, and in fact, that's what it says right up the top here. If you want to add or subtract two fractions together, it's always easier to do with equivalent fractions. You saw when we were looking at the strips, you could actually visualize it. So I'm going to try to visualize it for you right now. Okay. Let's say you were working on something like, let me give you a number, 3/4 minus 5/8. Okay. So if I try to put 3/4 together, okay, and we're talking about 3/4 of a whole. Let's get the 3/4. I'm going to make a tile. So there's my 3/4. Now that in itself is not a problem, but if I want to add to it 5/8, or take away, or have 5/8 as part of the thing, part of the equation, there's 5/8. So I'm going to take away 3/4 from 5/8. Now in its present way, you can't really do it. Now, when we were looking at strips, of course you could, right? You just determined how much was left after you took this part away, and you sort of came up with it. And you know as well as I do right now that the answer is 1/8. But I'm trying to get you to think about this at an easy level so that if we start really messing around with the denominators, you know what's going on. So 3/4 minus 5/8 is this chunk take away this chunk. In other words, that's what's going to be left from that line right, okay? So what we have to do is we have to come up with something that is equal between the two of them. And luckily, when we're looking at these denominators, we have one common denominator that we can use, which is the number 8. So 3/4, and I want to make it the same size. So I think 6/8 and 3/4 should be the same size. Right? You agree? All right. So if I'm going to take 5/8 away from 6/8, what does it leave me? 1/8. Okay? Now, I know you know this theoretically, but to actually see it in operation might make a little more sense for you than the other way to do it. Okay? So let's take a look at another number just to play around a little bit. How about 3/2 and 4/10. Okay, hang on a second. We're playing with 3/2. We can't do 3/2. Boy, wonder why. Well, hang on a second. Let's clear this off here. Let's do 2/2 and then another 1/2. That's 3/2. Because, well, we've got 1 and then a half, 3/2. The other number that we were talking about was 4/10. So let's push this all the way up to 4/10. I'll make a tile and I'll put it here. Okay, is there something here that really looks close? Okay, well if I do this, no, it won't be as easy as just moving a piece. Okay, so what I have to do is I have to find a common denominator. Well, we can do a common denominator in two ways. One common denominator that comes to mind is 10. Doesn't that work out? Because I can multiply both these numbers by 5 to get to 10. So just to test that, if I multiplied 2 by 5 to get to 10, and I multiplied the 1 by 5, it would be 5/10. I'm going to make a tile, and you know what? It's exactly the same size. So it's an equivalent fraction. So I'm going to put that up here, and I'm going to put down this here. So if 5 out of 10 is the same thing as 1/2, then if a whole is, then it's got to be 10/10, right? That makes sense to me too. And just to test it, We're going to make 10 out of 10, make a tile, put it there, and look, it's the same size. So I'm going to bring that back over here. So 10 out of 10 and 10 over 10 and 5 over 10 are the same equivalent of 1 and 1/2. Okay. But I want to take away 4 tens. Well, how much do I have total up here? I've got 10 plus 5. I've got 15 over 10 up here. And I got 4 over 10 here. If I take that away, how many tenths do I have? Yeah, I've got 11 tenths. Or to take it from that improper fraction of 11 tenths and make it a mixed number, it would be 1 and 1/10. Okay? That is as simple as you're going to be working on it tonight. Okay? Go through the work, give it a shot, see how it turns out, then let's work on it tomorrow and make sure that everything is clear for you before we move on. Okay? Good luck.